Welcome everybody from CAFE, the BU and Harvard Climate and Health Research Coordinating Center. I'm Rachel Nethery and I'm a CAFE team member. And today's seminar is super exciting, discussing something that we're all interested in at this moment, which is emerging issues in AI and data science, specifically in the context of environmental and climate and health research. And so we're really fortunate today to be joined by two experts in this emerging area. Marianthi Kioumourtzoglou and Joan Casey and Dr. Joan Casey. Dr. Marianthi, I'm gonna mess it up this time. Kioumourtzoglou is a professor in the Department of Epidemiology at the Brown School of Public Health and at the Institute at Brown for Environment and Society. And her research focuses on applied statistical issues in environmental and climate epidemiology, including quantifying and correcting for exposure measurement error, characterizing exposure prediction uncertainty, and assessing high dimensional and complex exposures in health analyses. And Dr. Joan Casey is an associate professor in environmental and occupational health sciences at the University of Washington. And she's an environmental epidemiologist who focuses on environmental health, environmental justice, and sustainability. And her research uses large secondary health data sets like electronic health records to study the relationship between emerging environmental exposures and population health across the life course. So thanks so much, Marianthi and Joan, for leading us in this discussion today. Really excited to now turn it over to you with just one final word to participants. You won't be able to raise your hand or unmute yourself, but you can put questions in the chat as we go. We'll have a Q&A time at the very end of this, and so hopefully we can get around to a lot of your questions. So please put in questions, comments, whatever, into the chat as we go, and we'll address those at the end. Thanks, guys. Handing it over to you.
Thank you very much, Rachel, and the full CAFE team for inviting us to talk about AI and data science and go a little bit, like this is a short presentation. It's just an hour, so we don't go too much into anything too deeply, but just an overview of what lies, once you open the hood a little bit. So we'll start with some definitions and examples. This is a tweet I know from, as you see, 2019. This is not very recent, but I think it's very funny, and it sets up where we are very well. When we raise money, it's AI. When we hire, it's machine learning. And when we do the work, it's logistic regression. And this is by Daniela Witten, who is a professor of stats and biostats at UW, and overall awesome. Well, I haven't met her, but I'm a huge fan of her work and research. And so I think it's important to understand what AI is, what machine learning is, and how, when we use which, and how we talk about using them. So actually, machine learning is just a subset of artificial intelligence. These are two graphs that basically show the same thing, one from NASA, one from IBM. Artificial intelligence was first introduced as a concept, not as a term yet, early in the 50s by the great computer scientist Alan Turing. And then later in the 50s still, the term was coined by McCarthy, a computer scientist at Stanford. So, but basically artificial intelligence means is how can we use machines to simulate human intelligence, as the name says. Now, in the 80s, a field started popping up called machine learning. And that basically means that big data sets, we'll go into definitions about what machine learning is. Machines use data to learn from them. A big revolution in the field was the introduction of deep learning in 2010s. These are machine learning models that mimic human brain function. They're multi-layer neural nets, basically, that can learn features automatically from the data. That really revolutionized the field and gave rise to Gen AI, generative AI, that use deep learning models that are foundational models for Gen AI that create original content. And that original content, most of us are familiar with text, right? Large language models, but it can also be videos and sounds and photographs, so on and so forth. We'll first discuss machine learning, and then we will move on towards Gen AI. So, and specifically the focus here will be environmental epidemiology. It won't be machine learning in general, back to the 80s. But first, this is Google's machine learning definition. It is a subset, as we said just now, for artificial intelligence. It enables systems, and by systems, we mean algorithms and our machines, these are our computers, to autonomously learn and improve. And these systems or these algorithms continuously adjust and improve themselves as they get more experience or basically more data. The more the data, the better these machines, these algorithms, these systems will work. Now, something to be very careful about is that machine learning's goal was to maximize predictive accuracy while accommodating high dimensional and complex structures. In environmental epidemiology, that we do increasingly have high dimensional and complex structure, use of machine learning is extremely, extremely desirable, right? We do need these methods that allow us to handle this complex structure. But that said, prediction is not exactly inference or causal inference, right? We are usually interested in understanding associations. And many of these machine learning, especially deep learning models, are very, very black boxy. So according to a couple of MIT professors, the functions of a machine learning system are to be descriptive, predictive, and prescriptive. And that is not to understand biological mechanisms, as you can imagine. So is there really a use for machine learning in environmental epidemiology? Oh, there is, of course there is. We are increasingly in the field using machine learning to increase flexibility in modeling these complex relationships. For exposure assessment, that's prediction, that's pretty straightforward. But even in epidemiology, there are new algorithms. And now I'm giving one example here, TMLE, that is not that new anymore, but there are more and more being built that leverage machine learning, but also statistical inference to reduce bias in efficient and robust estimation. A couple of examples for machine learning for exposure assessment. It's used, as I said, in prediction models. My examples here are air pollution because I work a lot with an air pollution. So on your, what is this, left-hand side, that's a prediction model by D et al., that's the Harvard group, for PM2.5, daily PM2.5 concentrations, and that's an ensemble model of a neural net, random forests, and gradient boosting, all machine learning algorithms. On your right-hand side, that's a model built by Scott Weichenthal's team up at McGill. That's very exciting because what they did is for their first time, they leveraged satellites, but not AOD, aerosol optical depth, that has been used satellite to infer and predict PM2.5 concentrations, but images, satellite images, and they use deep learning, which is, the I guess, super cousin of just neural nets, because they have many, many, many more hidden layers to predict PM2.5. And actually, this model ended up doing pretty well, comparable with other models. There are also advantages for using machine learning algorithms in the epidemiology side of things, not only exposure assessment. TMLE was one example that was more general epi, and package that includes multiple methods that I'm very excited about, that was developed by Under Wilson's team, is treat DLNMs. Distributed lag models allow us to identify critical windows of exposure, and this package allows us to do so and run constrained distributed lag models using BART. BART is Bayesian additive regression trees that better allow, well, first of all, they allow continuous modifiers with the lags, which has not been possible to begin with before, but also it allows us to better capture spiked effects versus the potentially over-smoothed DLNMs that we all traditionally run. I'm very excited about this work. Now, this was a couple of examples for machine learning specifically. Now, though, I'll want to move over to Gen AI and use of GI in environmental epidemiology, with a caveat that it's actually too early for this. So AI can analyze, that's the benefits, unprecedentedly massive amounts of multimodal data. Multimodal means very different types, formats, very heterogeneous formats, data to find generalizable patterns and predict more accurately than ever. That allows us to integrate very, very heterogeneous data sources. And for example, incorporate exposomic information in our models, allows us to update the system with new data that's similar to what machine learning does that we discussed before, and also personalize predictions on the scenarios that we are interested in after the system has learned these generalized patterns. Two examples for exposure assessment, and these are two excellent examples that I don't know that we can use yet for exposures in environmental epidemiologic studies, but one is Google's DeepMind's GraphCast. That's an AI model for faster and more accurate global weather forecasting. Hundreds of weather variables it can forecast. And the second one is Aurora. That's a model built very recently by a group at UPenn that is a 1.3 billion parameter foundation model for the Earth system that at the same time can forecast, from air pollution to trajectories of tropical cyclones with great computational efficiency and very high accuracy. Now, what I want to emphasize here is that's 1.3 billion parameters, right? We are talking not just big data. These are 1.3 billion parameters, not rows in our data set. These are parameters being estimated. So you can imagine the complexity of these data sets. In environmental epidemiology, so not for exposure assessment now, sure, there is, of course, growing interest in deep learning, which is, the basis for the foundational models, including methods that can infer causal structures using, for example, variational autoencoders, that they can learn balance or disentangles representations that help reduce confounding or simulate interventions. These are all fantastic, but this is very, very much in very early stages, right? There's a lot of potential, but as I said, these systems need much, much larger data than if I have even a cohort of several thousand people. This is not yet big, the big data that these models require. So one example approach that I find promising is this gunite thing. I haven't seen it used yet enough in epidemiology to begin with, let alone specifically environmental epi applications. But this can estimate potential outcomes and individual treatment effects. This is the way the gunite works is a set of a couple of neural nets, and one generates data, new data. The second one checks and classifies if the data generated are true or could be real. So by doing that, the system better improves, continuously improves, and gives better simulated data that better represent the real data sets. And through that process, it actually learns better what the processes that led to the generation are. It's not perfect, and again, it needs a lot of data, as we said, but it is promising. But that said, all this promise doesn't come without caveats and second thoughts. As I said, these methods are extremely data hungry. So although our data sets are becoming larger and larger, we still, certain studies, especially if we're thinking like biomarkers for which a few hundred subjects could be considered large samples, but that's very, very modest for AI. Algorithmic fairness is still an important consideration. It was an important consideration for ML. probably heard about very notorious fails of ML. It's still very much so a consideration for AI. And if we ignore this, then historical and or structural biases can be perpetuated. The example I've been giving on this is, let's say you're interested in pulling in, as I said, the benefit of AI is many heterogeneous sources. So let's say I'm interested in understanding the effect of tropical cyclones on some mental health outcome, and I want to understand how people experience tropical cyclones. Then if I do that, I might very well want to incorporate in my analysis information reported in the local news. Gen AI can let us do that much easier than otherwise, but what is reported in the news? Whose voices are captured in the news? Right? All these things that if I don't think through carefully and I just randomly pull in, then I may give more weight to certain voices, or potentially even worse, have voices, important voices, never be incorporated in my models. So we are interested and need to be careful for our AI systems to be fair. Reproducible AI is another considerations. I said that 1.3 billion parameter example before. These results can be sensitive to code details, random seeds, hyperparameter settings, especially if we start running these models without understanding better how they fit and they work, then our results could be very different if I were to run the same analysis as with Joan, let's say, and we made different assumptions. So we want our results to be reproducible. What's the point otherwise? Interpretable and explainable AI. If we just want to maximize predictive accuracy for PM2.5 concentrations, maybe that's not so much an issue. But in the epi side of things, we do most of the times want to understand what's happening. Deep learning and these foundation models are very, very black boxy. So there is this disconnect there. So there are post hoc tools that can allow us to get some better interpretability of the results, but they do not improve causal accuracy, and also they don't guarantee interpretability either. So that's something to keep in mind when we run these things. And then John will talk more about this, but also sustainable AI is very important, because AI is not only data hungry, as we said, but it's extremely resource hungry as well. So that's machine learning and Gen AI. More general, I'll continue on data science. That's basically the science that allows us to harness the power of the data to gain knowledge. That's a critical part of the definition. The key elements of data science are, again, big data, and we have to consider computational scalability if we don't want our models to run for 6 months. Domain expertise is important here because the knowledge part is key. So if we have non-experts running models and getting results, or what goes in comes out, like the quality of what goes in influences the quality of what comes out. So that's why domain expertise is very important. Understanding of statistics and machine learning and the use of these tools to deal with data obviously is extremely important, and that requires coding. And it's nice to have good and informative and interpretable data visualization so we can disseminate that knowledge. And reproducibility, replicability, extremely important. And for all of these, as you can imagine, training on all of these, including domain expertise and stats and coding, is our key for this to be successful. Data science in action, a couple of examples that I like here are these are our packages specifically that exemplify data science. One is Antonio Gasparini's DLNM. This is the predecessor of the DLM trees that I discussed earlier. But this package really revolutionized and allowed all of us to start looking. And I just realized I must have said revolutionizing like 10 times already. Sorry about that. But this package, the existence of this package allowed many, many of us to start looking into critical windows of exposure for our outcomes of interest. And then on the whatever right-hand side is BKMR, Bayesian kernel machine regression, that was developed by Jen Bob and Brent Kuhl. This is a mixture method that allows us to accommodate, the high correlations among mixture members, environmental mixtures, and get independent associations and overall effect. Great, very different examples that leverage stats, that the coding is there and it's nice. And well, BKMR is not that computationally efficient, but they are working on it and they are improving computational efficiency. I talked about the code. We still need domain expertise to understand which co-founders to put in the models, right? And interpret the results. The packages cannot do this for us. So these are super, super user-friendly software. A concern with that is that it benefit, very easy to use. Disadvantage, very easy to use, which means many people can use these tools without fully understanding what they're doing. And that is a problem if something's wrong with a model fit or if the model hasn't converged, and then whoever is running those does not have the ability to check that and correct that. So once again, training is extremely, extremely important. And with that, I will give it over at Joan, who picks up now, and I'll be turning the slides for her.
Thanks, Marianthi. Okay, so Marianthi really got into some of the definitions, analytically, how we are using some of these tools and how we might use them. I'm going to talk about how we are currently using these tools in our jobs, and then zoom out bigger picture, kind of ethically, what do we think about this, and talk about things a bit from an environmental justice perspective. And then we'll have some time for more discussion afterwards, because many of these topics are very new and require discussion rather than slides. Okay, so what are we doing currently using AI in health studies and kind of in our jobs? Things like editing text for manuscripts and proposals. I feel like most people are doing this now. I teach a grant writing class for doctoral students here at the University of Washington. And at the end of the term, I ask students to write a one-page AI statement telling me how they used AI in the crafting of their proposal or throughout the course. The first year I taught the class, one student said they used AI. That was 2 years ago. This last year, every student used AI on their proposals. And I think that's pretty representative of kind of this vast shift that we are seeing. Two, we can bounce ideas, check concepts, engaging with AI. So, how might I understand the impact of PFAS on infant mortality? Or I'm a doctoral student and I want to know, what are PAHs? Like, let me get a quick snapshot, a summary of the literature. It works pretty well this way. And also to kind of integrate topics with each other. You can have a dialogue. You can do things like generate graphs for presentations. I did this recently and attributed, an interrupted time series figure to Claude AI because it was a lot faster for me to write 2 sentences of human language text and have them produce the figure for me rather than going into R and trying to code it myself. Help with code. I'm going to talk a little bit more about that. I think it's a major place that we are seeing enormous shifts, and that's going to have implications for our training. I think we can talk about that a bit later. And then help with things like literature reviews. Okay, thanks, Marianthi. Next slide. Okay, coding. All students are familiar, and some faculty still get to code. But before Gen AI, we all spent a lot of time Googling around how to do certain things. For example, I was always Googling how to rotate my axis labels 90 degrees in ggplot. And we all were visiting Stack Exchange all the time, I think. I was looking this up because I thought of this as a major shift. And since 2017, when Stack Exchange kind of had peak internet traffic, they've seen a 75% drop in visits to the website. And that's because it's easier to engage with one of these Gen AI tools rather than Googling around on Stack Exchange with other humans. So there are these tools, right? So ChatGPT, GitHub Copilot that can provide really quick feedback, coding advice, and examples. So Copilot, for example, is one that can integrate into R itself. And what's it doing? It's generating new content. So that's the gen part. It's generating new code for us based on patterns it's learned in the training data. It used billions of lines of code from GitHub to train. And it's, again, it's not, just finding code and giving it to you. It's actually creating new code that's relevant to your example. And it also can autocomplete. This is something that a lot of my students have been using. It can kind of predict for you what it thinks the next lines of code will be, which can be helpful if you need to write thousands of lines of code. It can do the thing that I think is the biggest shift, and I'd like to talk about more in the Q&A period, is how it can translate natural language into code. And so what does this mean in terms of teaching students to code and what that will look like in the future? So generally, though, this can save a lot of time, and it can encourage good coding practices if it can use consistent formatting and consistent notations throughout. It also can have some downsides, I think, that we'll touch on a bit. Yes, so Marianthi talked a lot about implementing advanced statistical methods and having these tools. I asked AI to draw me a little kid with keys in an airplane, because it feels like we're giving people these amazing tools. We aren't necessarily requiring they understand the underlying theory and the decisions that need to be made to go in to utilizing these tools. And so that, again, I think links back to how we train students and what we're going to prioritize going forward. And the last part is, Gen AI can produce really beautiful long scripts of code very confidently, but it may be extremely wrong. And so without the ability to assess whether or not the code is correct or incorrect, I think we can quickly, students or even, more senior people can go down a difficult road. Okay, literature reviews. Gen AI can be extremely helpful in identifying relevant papers very quickly. You can use this if you're writing a discussion section to make sure you don't omit key papers. It can also summarize findings very efficiently. So rather than reading, a collection of 20 papers, you can summarize the key points. It can save a ton of time, and I think is an excellent place to start. Question about training and whether it can replace kind of the status quo of how we teach students to read papers and summarize them is up in the air. Go ahead. And here's some downsides. It can make up papers. It's told me I've written papers that I never wrote. It often can lack access to full text and have to say, sorry, I can't get behind this paywall. It can't critically assess the study quality or causal claims. It can talk about biases that might be introduced by specific study designs. It is not yet to the point of doing kind of what I would say a critical human analysis of an epidemiological study. And it can produce biased or overly confident summaries, especially depending on how we are engaging with Gen AI. Okay. Ethics, please. Yes. So turns out AI is not that great for the environment. Energy consumption. So as of 2024, data centers are using about 4% of the electricity in the United States. By 2028, that's projected to be somewhere between 6.5% and 12.5% of all US electricity. So that's just 4 years from now. And that is going to result in increased costs of electricity. Estimates are around a 9% increase on average by 2030. What about air pollutant emissions from these facilities? So we have greenhouse gases to be concerned about, and we have other emissions. Estimate is about 56% of electricity used by data centers for both computing and cooling those facilities comes from burning fossil fuels, thereby emitting greenhouse gases. Data centers often also rely on diesel generators for backup or additional power. And as we know, diesel generators are extremely polluting and can cause things like noise pollution that might affect nearby communities. In addition to being energy hungry and data hungry, these centers are very thirsty. There's a lot of water consumption going on. This water is used for cooling facilities. An example of how this is sort of escalating, comparing 2022 to 2023, Microsoft saw about a 34% increase in water consumption for their company overall. This is, mostly attributable to data center use. It's estimated by 2027, AI is going to use more water annually than the country of Denmark. So a lot of water is being used, and we have to think about where these facilities are being sited if they're already in drought-prone or water-scarce regions. There's additional resource depletion, so we have to mine rare earth metals in places that are already potentially experiencing severe environmental stressors, so things like cobalt, lithium, coltan. We're also clearing land to build these data centers in new places that can do things like disrupt migration patterns of animals and birds. And so fairly significant environmental impacts, and these externalities have not been a big part, to my knowledge, of the discussion thus far. Next slide, please. So this becomes very quickly an environmental justice issue, and I would say an energy justice issue, as we are trying to go through this energy transition, getting off fossil fuels and moving to clean energy. But at the same time, when we're seeing this huge growth in demand for electricity, I suspect that will slow down the energy transition, because we simply cannot build out solar, wind, and other renewables at the pace needed to keep up with how much electricity these data centers need. We've also seen data centers and big tech thus far kind of descending on the US South, and data centers moving into areas where there is a good electricity supply. Data centers, as of now, are often receiving tax breaks because they are thought to bring high-income jobs to communities, but it's not clear how much that is happening to date. It's also true, and what this figure from Bloomberg is showing, is that the electricity use at these data centers can drive up the price of electricity for local consumers. This recent analysis by Bloomberg found that communities located near data centers appeared to be paying 100 to 200% more for their electricity than they did just 5 years prior. And so AI and these data centers are receiving in some cases breaks from utilities, but that extra cost is being passed off to the consumers. So what do we need? In environmental health, one thing we often turn to, and very likely should turn to here, are regulations. So we have to think about quickly, because this is happening very fast, the externalities of this build out of AI. There are counter narratives around the use of AI actually to help the clean energy transition, to help building efficiency. There are many of these applications to, presumably help society move through this transition and stave off the worst impacts of climate change. But we also need to consider the very real environmental and social externalities of these facilities. So we need to think about whether we should be giving big tech and AI and these data centers tax breaks. Perhaps we should be avoiding these incentives. We want to be thinking about mandatory reporting requirements, holding data centers accountable for their environmental impact, and giving us the information we need to make smart decisions going forward. But this is something, as this industry grows very quickly, that we'll need to act on at that pace. Okay, so in summary, and then we'll move to Q&A. AI is a promising tool for EH studies. This is, I think, especially true for complex and high-dimensional data. We're in the early stages. There are limitations. We need to think about fair AI. We still need to use theoretical basis in our training to evaluate causal assumptions. We need to think about all the concepts we've learned about in grad school and beyond, like generalizability and transportability, that don't go away, that Gen AI can't solve all of the problems. we need to consider sustainability and environmental justice in this process. And, you know, things can be helpful, but yes, great. The last point here is that AI can complement, we think, but not replace the training that we've received in epi, stats, and other subject areas. But it can be a tool that we can leverage in, and very much should. All right, thank you very much. And we're gonna have a bit of a dialogue with each other.
Yes, hi all, I'm back. So we decided, because it's not possible to put everything in slides, to just, and also, you know, to make this more interesting for attendees as well, to, as John just said, interview each other for, you know, the next maybe 10 minutes and leave the last 10 minutes for open Q&A. And we see that many of you are popping questions down. Thank you very much. Joan, do you want to, oh, I kicked this up. John, how are you using AI in, and clearly we have not practiced this part. How are you using AI in your research or teaching right now?
Well, that's because Marianthi told me if we didn't practice, it would be more natural. So we didn't practice. And then she wore her tech sweatshirt. So we're ready to go. Okay, so how am I using AI? Not in a super deep way. I'm definitely using it to help myself process information. And I would say the thing I'm doing the most of is I'll write a sentence and I will be checking if other people would think the meaning is the same as I do. Especially when I have kind of a highly complex sentence in a paper. I want to make sure what I'm trying to say comes across. And so I might put that sentence in and ask for kind of iterations on it. The other thing I do is definitely when I have to do things like write letters of recommendation, help me build out some of this that I can then edit, provide a lot of bullet points. So these are spaces where I'm using it. I don't get to code really anymore. I think I definitely would be using it to code if I was. And when I get questions from students, I do. What about you, Marianthi?
English not being my first language, I have increasingly started to use it to check my sentences. I found that I'm becoming lazier with that because it makes me write sloppier sentences. I'm like, yeah, you know, Gen AI will fix it. I was very proud of myself. I wrote 2 days ago, a very small pilot grant. It had to be 1 page. And I was like, no, I'll do it just by myself. And it's, you know, after using AI for a while, it was like, wow, this is hard, man. I have to write this in good language myself, which only means that I need to do this more actually, because this, like, if you don't use it, you lose it, right? So that's what I've been using it for. And the other thing is TidyR came out when I was already done with postdoc and kind of had stopped coding, so much so I code in basic R still, occasionally. At some point, my students unanimously voted that I should stop giving them code and giving them coding advice. So now I use AI to translate base AR to R that they would understand if I want to give them advice.
Yeah. That's actually one thing. That's one thing I was going to say during the coding section is also can help us translate between languages, which is really nice. So someone sent me a Python script yesterday and I was like, my lab doesn't really code in Python. There's a couple of people that do, but this would be now like pretty readily translatable into something like R. So I do think that is an exciting piece. Yeah. Okay, let's talk about training our students. This is the thing I think I'm the most stuck on. And I want to hear your thoughts. So what do you think kind of the key elements are of training doctoral students in EHS, and how are we going to teach these skills in this new world of heavy AI presence?
I'm increasingly getting worried, and that's maybe conspiracy theories on my part, but seeing how much I increasingly depend on AI, I'm worried that this might happen. And I do think, yes, it makes things so much faster, as you said, to write a reference letters that would take me before hours. Now I do the bullet points I want, and I have a very good relationship with ChatGPT, and he knows my style. So I'm like, you have to write this in my style because you can, but I think that means that I'm losing a part of myself, an ability, a skill set that as a skill set will not be useful in the future itself if we have AI. But I cannot help but wonder, how will that impact the function of my brain in general? So that's my worry. So I think what I want to do is encourage students to use AI very, very critically, especially thinking all the resource concerns that you said, right? Just turning to AI for everything. Us changing practice will not, there are 8 billions in this world. That takes more of us. I understand that. But I think having training sessions of using AI together, for example, on how they could interact with AI for text or for code or for even asking ideas. Sometimes I right now do not know if they come to me with ideas, how much is just them versus AI. And again, is that important in the future? Maybe not. But then then what's my job, right? My job is to train them. If you remove me, then I don't have a job. So very biased answer, but help them together next to each other, use AI so they can retain the critical thinking while generating ideas, writing text, writing code, whatever. What
Yeah,
about you?
I think that's right. I mean, to me, the key thing is scientists as critical thinkers is the goal of a doctoral program. And so, yes, some of the tasks will differ, but at the end of the day, we have to figure out how to train students to think critically, because that, I think, is even more important when information can be kind of disguised as real in the way we sometimes see it coming out of Gen AI. The thing that I'm curious to talk a little bit more about is coding. So let's say we have a student starting their PhD program in 3 years. Right now, the way people interact, I think, most effectively with AI, with coding, is they already know how to code and they're looking for help for specific things. And when AI gives them code back, they can assess whether or not it's correct to an extent. So in the future, though, is knowing how to code an important skill, or is it knowing how to write in natural language what you want it to do and think critically through the steps of performing an analysis, but actually needing to code? I'm not fully convinced anymore that is, while we all spent a lot of time on that during grad school, it's not the coding that's so important as the thinking. And so how do we teach people to think while using a mechanism that's entirely different than the one we were all trained in, potentially?
I actually absolutely agree with that. And I think some computer science department has prelim courses in thinking algorithmically,
Yeah.
which is independent of language, right? What's the process? I agree with you. So knowing how to code is itself, because even if I'm a good coder, Gen AI would still be a much more efficient coder than me, right? And better. But I think still training for the methods. Or I think for me, is that the problem is what I've seen with my students. And I was lucky enough to catch it once. Otherwise, I don't know that I would have thought about it. But I was sitting with a student and they were it was a complex stats question. And they were like, okay, I don't know how to actually code this. Let's ask together ChatGPT. And ChatGPT gave something that was wrong. It ran, it gave a solution. It was methodologically very wrong. And now, so the students okay, we have an answer. And I'm like, yeah, but that is a very, very wrong answer, right? So knowing the methods, that can never, AI is not a statistician. So I think going back to critical thinking, yes. So I agree, not the coding itself, but understanding what we're asking to do is important. Let's move on because we have a couple more minutes. How concerned should we be about algorithmic fairness? Maybe this is the last question, Joe. This is especially just for the open Q&A as well. This is especially important in the context of health disparities research. Do you have examples?
Yeah, I think we absolutely have to be concerned about algorithmic fairness. I mean, there this is multifaceted. This is, I think, comes back to kind of the crux of science, where if the data we're putting in is not unbiased and not of high quality, the results we get out will not be those things either. So I think there's many examples of this in the world of AI where actually the logic we have applied to science previously still fits here. And we need to step back and think about the general principles of what we're doing and why, rather than kind of allowing ourselves to just walk through steps that we've gotten used to doing. So from a health disparities perspective, we've seen problems with this arising in clinical settings. For example, looking at either the data available among people of different racial and ethnic groups, or how information is recorded in electronic health records about people from different racial and ethnic groups, and where human biases are showing up in that data output, and then that data is being fed in and can give us the wrong recommendations. And so we need to be extremely careful about that. And I think when things are fast and easy, we want to trust them because it makes our lives simple. But we have to force ourselves as scientists to continue the hard work of critical evaluation of evidence that starts with the data inputs and ends with what results we see and how we think they are translatable into action. I don't know if you have additional thoughts on this.
I have a follow-up question, yes, because I 100% agree with what you're saying, but would AI give more power to communities, so for community work, who do not have this training? And is that a good tool and a good idea? Sorry.
Yeah, wow. Possibly. It's possibly that is possibly helpful. I mean, I'm thinking about if this example of you don't know how to code, but you do know how to logically think through a question. Yeah, maybe you could get a lot of the way there. I still think
Or access to data if you don't know where they are, right?
Yes, I think this can be democratizing. I think it also can be problematic quickly.
For all the reasons you
Because we
said.
then live, I mean, I think one problem that has arisen in the United States more generally is that we live in a world of multiple realities and people living with different truths. And I think ideally in science, we land on a truth together and make decisions from that. And so I worry a little bit about the lack of scaffolding around people being able to ask and answer questions. But I do think there is promise there. But it's not obvious that it's 100% a good thing.
I think I agree. And also if we are worried about the PhD, not only our PhD students not understanding the methods, right, and not being able to get something if it's wrong, then someone with zero training on this is even in a more vulnerable position of producing something that's quite wrong without necessarily being able. So I agree with you. It is tricky because yes, it's, you know, that balance. Rachel, should we continue or should we open up?
It's
There's a lot
totally
of
up to you guys. There are some amazing questions in the chat. They're
Go
pretty
to the
awesome.
chat.
Cool. Yeah. Okay. If you want, I can try to sort through some of them. Since you guys are talking about ethical stuff right now, maybe we'll ask a few of the ethics related questions, and then we can circle back to more like practical aspects. So Ellen Considine asks, some of the students in my undergraduate stats course have actually objected when I suggested using AI for studying help on the grounds that, quote unquote, it is immoral. And I believe they're mostly referring to environmental impact. Any thoughts on how to respond to this?
So many thoughts.
Yeah.
Yes. So for the reason we said, I don't disagree with that. But that said, there are approximately, like, if not everybody on the planet right now, because there is justice about who also has access to internet, etc., right? But billions of people are using AI. If 10 students do not, it will make, unfortunately, zero difference. So I think this makes us, I also try to not generate many figures, etc., but I think that helps me more than the planet. So I think instead of individually not using AI, pushing for the regulations that Joan talked and putting our efforts together to push for that is much more important, and that's what should be prioritized. I don't know, Joan, how you feel about this?
I think I mostly agree with that, but I think it's also a moment of self-reflection. So I think it's kind of great that these students are pushing back in this way, and it would be nice to unpack what they mean even more. Because, you know, I saw another Philip in here has this caution about, you know, gastroenterologists are becoming worse at spotting polyps after relying on AI. So there also is a much bigger conversation, and Marianthi and I are neuroscientists or psychologists, about like what is happening to the human brain by using these tools, and are we okay with that? And so I think that is also potentially part of this question. And I think undergraduates are like the best people to, be thinking about this. The question is like, how do we want to think in the future? It's like a very fundamental question. So yeah, having a dialogue is great, but I agree, you know, these kids boycotting probably doesn't change the environment, you know, the CO2 emissions associated with this.
So many cat videos, AI cat videos out there.
So many. I don't know what to do about cat videos.
Yeah, and the cat videos are probably using way more data to produce than our like requests for code, right? On that topic, I mean, this might be too difficult a question, but I think Shindy, who asks, in your teaching, how do you balance the desire to introduce students to the latest tools and the need for them to build muscles before becoming proficient?
Well, I don't think, at least in my teaching, I haven't had advanced students at that level yet. So we're still introducing them to basic epi methods and stats methods. But in general, about use of AI, Joan mentioned it briefly, in the classroom is very tricky, right? So the class I taught last year, AI was not forbidden, except in the quizzes. But the caveat was, not the caveat, but in the syllabus. You can use AI, you need to let me know when you did it. If it's wrong, you get points off. And like it was still, like I still had to fail people because in the quiz, they're 5-minute quizzes, 3 multiple choice, and still they were using AI and not even double checking the questions and the answers. And that means that they also are not paying attention in class. So it's not, Cindy, not your question, because I don't know how to answer your question, but I do think it's important to, again, critical thinking here and train the students to critical think while using AI.
The thing I'd add to that is we all have a lot of work to do thinking about what we are trying to teach students and what are the core competencies of an EH doctoral program.
100%.
Because then from that stems the answer to this question. If we want students to think critically, so an example of something I do related to this in my class is, it's a grant writing class, so they need to do literature reviews and they need to summarize. So I have them pick as like a small sliver of what they need to research. I give them 25 minutes to do it using AI. I have them write a summary, and then I give them an hour to replicate that process without using AI. And then they write up what they learned from each process and what was missing from the original AI interaction. So I think that's one thing. And that's sort of showing them like, you still need to use these other tools and you need to think. I also think there's a really critical training piece around, though, how to effectively engage with AI. So Marianthi said something really interesting, which was ChatGPT knows my style. So Marianthi's engaged with ChatGPT in a way enough that they know what she's looking for. They know the type of information she wants. You can have, one of my friends works in AI now, and he's talked about, he has like a 2-page script that he gives to AI before he works with it that explains in ways in which he wants to engage and the ways in which he expects information to be presented to him. And so having students work through that, and there also could be assignments that are like, engage with AI on this topic. And we're then assessing like, what questions are you asking? You get information from AI, and now you are critically thinking and you're going back with additional questions. And like, what does this look like in terms of knowledge generation and clarifying our thinking on scientific concepts? Go ahead, Marianthi.
Adding up on that, 100% agree. I think also, and back to what you said at the very beginning when you started talking, is what are the core competencies? And I used to sit in the EH department, EHS. Now I'm in an EPI department. I'm here to teach EPI and teach environmental health and potentially exposure assessment. I'm not here to teach neural networks. That is a class that if the students are interested, can go and take at a computer science department, or I don't know, applied math. I don't know where you would get that. But I think that's very important because one, I would not be able to teach it well enough. And two, that means I'm not teaching the epi that they do need to know if they want to be epidemiologists.
This is awesome. Thanks, guys. Maybe one more ethical question that's come up a couple of times in the chat. How should we appropriately acknowledge and disclose the use of AI tools in preparing our research? And then someone else followed up and said also in the context of grant writing, how do or should you acknowledge AI use?
It depends how you use the AI, right? Because if you used it to tweak just a couple of sentences, do you like, I don't know that that's something that you need to acknowledge or to help you with a code. But if you used it for your literature review or for idea generation, then that's not acknowledging AI. That's acknowledging the work of everybody that AI used. And so I think in that case, I don't know if journals would accept that, but I think for me, the moral and honest thing to do is I acknowledge everybody whose work is on the internet and AI gave to me. Joan is
Okay. Okay. So I think this speaks to the fact that we need some collective agreement about how we do this. It doesn't exist currently. Some journals have no guidelines. Some journals say you need to declare if you used AI and what AI tools you used. I agree with Marianthi that this is all on a spectrum. So for example, I use Grammarly, which is AI, which edits my sentences or tells me where I'm missing commas. When Marianthi's not there to explain to me when an em dash should be somewhere, I count on Grammarly to tell me. So that's AI. I don't know that I feel I need to disclose using Grammarly in a grant application, but there is like this, there's then the very other obvious end of the spectrum. And I think we need some sort of tool that is similar to any of the manuscript writing guidelines like Strobe, where we're declaring things about our manuscript that allow us to declare how we used AI, from check I used Grammarly, or even I think like the built-in Word spell check stuff now is AI, to, you know, the more extreme. I used this for my entire literature review to inform how I wrote the introduction of this paper, or the idea for this manuscript came from AI. Though like that seems important. And then I just see this question about in grant applications, a similar question. So I think this right now is being decided by the funder. So I know at NIH now they're saying don't use AI, we're going to run this through. And they're saying when you're reviewing grant applications, absolutely don't use AI. And so I think there are going to be different decisions made by different grant making entities. But I think similarly, we need norms, because I bet most people are using AI in their grant applications now, and we don't want kind of differential gradings and scoring of proposals based on people reporting differentially on AI use at this point. So I think this does speak to kind of a gaping hole in our conversation as scientists around how we're gonna handle this and report it to each other. And even maybe something like, here are the questions I asked AI. Like, when I was working on this manuscript, like it's an extra document that could include that.
Actually, that's a very good idea. I like that idea.
Yeah, that would make it a lot more straightforward than trying to categorize how you used it, because sometimes it ends up being a mesh of like using it in a variety of different ways. So that would be really cool. Do you guys have time for another question or two, or do you need to hop off now? I see that it's a couple of minutes after.
I can do one more question, but then, yeah.
Okay, maybe we'll end with a practical question then. I also have this question, and Anne-Marie put it in the chat. Do you have any recommendations for how epidemiologists can keep up with AI tools and methods? Are there helpful online courses, or is it just about trial and error?
Well, I think it's important here to distinguish what we mean about AI, right? Do we mean, for example, these methods Like how do I even run a deep learning model? What's Ganite? Is that the question? Or is it how do I more effectively engage with LLMs to help me with idea generation and text? And again, I think if it's the former, then I would go to a computer science class, honestly, that they are the experts, they are developing these methods. And I think maybe we should have like more cross-pollination. And also always, what I say is when we do use, because it's AI now, it was machine learning before, it doesn't matter, right? Just using these methods off the shelf is not automatically okay because these methods were not developed for environmental epidemiology. So using them with help from experts, relevant experts, that's not me, that's a computer scientist, that's a biostatistician, to make sure that the method is doing what we want it to do or how can we adapt it, then that's extremely important. And the second, if it's the second, how we interact with LLMs, then that's the training part that we discussed at the very beginning of this Q&A session, I think. I don't know if that answers the question, John.
Yeah, I agree with all that. The things that have been most helpful for me, and also hi Anne-Marie, are talking to other scientists about what they're doing, basically, because right now it seems like there is very little formal guidance. And so a lot of this is word of mouth. So I think incorporating, and I think this is happening at our major conferences, sessions on this topic, where we can talk about what people are doing, talking to our students who are heavily using these tools. I think it's about having an open dialogue now. I haven't found any, specific kind of one-stop shop that keeps me up to date on this stuff.
Thank you, guys. This was a fantastic discussion. It's so good to hear from other people who are thinking about the same issues, to know that we're all kind of grappling with the same things. So thank you guys so much for your thoughtful presentation and Q&A. Really enjoyed this. And thank you for your time to you guys and the audience. And the recording will be posted, if that's okay with you guys, within a week or so.
That's all fine. Thank you for the invitation. And thank you everybody for being here.
Yes.
Have a nice day.
Bye all.
Thanks.